Okay, we're going to start the test review for AQR over sections 8 and 9. We already had part of the last test was over scientific notation, but I wanted to go over that again. It's going to be on the test. On the test on Friday, you won't be able to use a calculator. You can on the review to double check your work, but you can use the review on the test on Friday, but not the calculator. The problems and numbers will be different, but the process should be the same. So we start with number 1. Express this in scientific notation. We're going to need to move the decimal from its current location. We're going to need to move it to the right until we only have one number that's not 0 to the left of the decimal. So that means it's going to need to move 1, 2, 3, 4 places to the right. So in scientific notation, this will be written as 7.56 times 10 to the negative fourth. It'll be negative because the original number was very small. Because we moved the decimal to the right, it'll be negative. On number 2, the decimal is currently located here. We'll need to move it 1, 2, 3, 4 places to the left. So this would become 8.235 times 10 to the positive fourth. On number 3, we only need to move it 1 place. We're going to move it to the left. So it'll be 1.05 times 10 to the first power. Now on number 4, we have 30 squared, which would be 900 times 60 squared, which is 3,600. So the answer there would have 4 zeros plus 6 times 9 is 54. Carry the 5. 3 times 9 is 27 plus 5 be 32. So written in scientific notation, we would need to move the decimal from here to here, which would be 6 places. 3.24 times 10 to the 6th. For number 5, 6, 7, and 8, we need to remember that in logs, the base, and then you have, this is more like the answer, is equal to the exponent. So that means that 10 to the 4th power would equal x. 10 to the 4th power equals x. So 10 to the 4th power would be 4 zeros. Number 2, we have the base of 2 to the negative 3 power is equal to x. 2 to the negative 3 power is equal to x. So if you remember that 2 to the negative 3 is the same as 1 over 2 to the positive 3, which is 1 over 2 times 2 is 4 times 2 is 8. For number 7, 10 to the x power is equal to 1,000. 10 to the x power is equal to 1,000. Well, if we refer back to the first problem, if 10 to the 4th power is equal to 10,000, 10 to the 3rd power is equal to 1,000. So that means x is 3. 8. 2 to what power is equal to 64? Well, 64 is the same as 2 times 32, which is the same as 2 times 2 times 16, which is the same as 2 times 2 times 2 times 8, which is 2 times 2 times 2 times 2 times 4, which is 2 times 2 times 2 times 2. And then the 4 is 2 times 2. So that means 1, 2, 3, 4, 5, 6, which is the same as 2 to the 6th power. So that means x, if 2 to the x is equal to 2 to the 6th, then that means x had to be 6 to make this true. 2 to the x is equal to 64, and 64 is equal to 2 to the 6th, then the x must be 6. Number 9, if we can change these into scientific notation, we would get 8 times 10 to the 1, 2, 3, 4, 5 to the negative 5th power times 2 times 10 to the 1, 2, 3rd power all over 16. That's not exactly in scientific notation. Times 10 to the 1, 2, 3 power times 12 times 10 to the 1, 2, 3, 4 power, 4th power. And so what I can do here is look at all the numbers with exponents of 10 and use my exponent rules. So the 10 to the 3rd and 10 to the 4th becomes 10 to the 7th on bottom. 10 to the negative 5th and 10 to the 3rd becomes 10 to the negative 2nd when you add those together. When you add the exponents together. 2 times 8 is 16. So on top we have 16 times x to the negative 2. And on bottom we have 16 times 12 times 10 to the 7th. So what happens is the 16's cancel. And if we, this is supposed to be a 10. If we have 10 to the negative 2nd over 10 to the 7th, and we try to subtract, and we bring, or actually we can just bring that down to the denominator and call it 10 to the positive 2nd, and then we're left with 1 over 12 times 10 to the 9th. I'll write that a little bit better. And 12 times 10 to the 9th is going to be, we're going to move it over 9 spaces, so it'll be 9 zeros. 12 billion. 1 over 12 billion. Let's take that back one step. I noticed an error. Always check your work. You noticed something I missed was that this was supposed to be 12 times 10 to the negative 4th power. So let's see what happens now. So how important those negative signs are. So this is 16 times 10 to the negative 2nd over 16 times 12 times 10 to the, if we add 4, negative 4 and 3, we get to the negative 1 power, okay? Which, if I want to make those positive, well, the 16's cancel, and so that would be the same as, I still got the 12 in the denominator. I'm going to take the 10 to the negative 2nd down to the bottom, 10 squared to the top. That means I'm left with 10 squared, 10 to the 1st on top. This 10 to the 1st can cancel with one of those. So I'm just left with 10 to the 0, or just 1 over 12 times 10 to the first, which is 1 over 120. Much better than 12 billion. Now let's look at matrices. We're going to do matrix on number 10. We'll do matrix E minus matrix A. We'll rewrite it. Matrix E is negative 2, 4, 6, negative 8, 3, negative 5. That's matrix E. We're going to subtract matrix A, which is 1, 2, 3, 4, 5, 6. And so our resulting matrix will be negative 2 minus 1. Cell 1, 2 is going to be 4 minus 2. Cell 2, 1 is going to be 6 minus 3. Cell 2, 2 is going to be negative 8 minus 4. Cell 3, 1 is going to be 3 minus 5. And cell 3, 2 is going to be negative 5 minus 6, which becomes negative 3, 2, 3, negative 12, negative 2, negative 11. Let's double check that on our calculator. Confirm that that's correct. Let's go to number 11. Two A plus E. Okay, 2 matrix A, 1, 2, 3, 4, 5, 6, plus matrix E, negative 2, 4, 6, negative 8, 3, negative 5, which this becomes, by 2 times matrix A is going to become 2, 4, 6, 8, 10, and 12. Still adding negative 2, 6, 3, 4, negative 8, negative 5. I'm going to add them together. Add cell 1, 1s together. 2 plus negative 2. 2 1, 2s together. 4 plus 4. 2 1s together be 6 plus 6. 2 2s together be 8 plus negative 8. 3 1s together be 10 plus 3. And 3 2s together be 12 plus negative 5, which becomes 0, 8, 12, 0, 13, and 7. Still, we'll check that on our calculator. And confirm that's correct. For number 12, D times B. Okay, D is 9, negative 6. B is 7, negative 1, 8, negative 2, 9, negative 3. Okay, so I'm supposed to, if I'm going to multiply D times B, I'm supposed to multiply this row by this column. It doesn't match up. That's because this is a 2 by 1, and this is a 2 by 3. And so since these middle numbers aren't the same, it's not going to match up. So this is a D in E. The answer does not exist. Can't multiply those two matrices together. They're not compatible dimensions. What about D? What about B times C? Matrix B, 7, 8, 9, negative 1, negative 2, negative 3. Matrix C, 3, 5, 7. So is it possible? Well, this is a 2 by 3. This is a 3 by 1. So it is going to be possible, and the result is going to be a 2 by 1. So it's going to be a 2 by 1. But it may take me more work, more space than that because my first cell is going to be 789 times 357. In other words, it's going to be 7 times 3 plus 8 times 5 plus 7 times 9. That'll be the first cell. The second cell will be the second row times the only column I have, be negative 1 times 3 plus negative 2 times 5 plus negative 3 times 7. So that becomes that's 21 plus 40 plus 63. All right, so that is 61 plus 63 is going to be 124. In the bottom, I have negative 3 minus 10 minus 21. So that's going to be negative 13 minus 21 would be negative 34. We'll check that on our calculator. Calculator confirms that those are correct. Here we have an application problem for matrices. Find the product in other words, matrix N is going to be equal to matrix N times matrix P. Let's make sure this is compatible. This is a 2 by 1. This is a 1 by 5. So they are compatible. The answer is going to be a 2 by 5 matrix. So how do we do this? Well, 460 times 10% is 46. 460 times 25 0.25. Made you do that on the calculator. That's 115. And we slide it over. 460 times 0.45 is 18. Oh. 207. Take that back. 207. Slide it over. Now 460 times 0.15 69, and then 460 times 0.05 is 23. We go through the same process down below. We use 360. We start over at 10. 0.10. 360 times 0.10 is 36. 360 times 0.25 is 90. 360 times 0.45 is 162. 360 times, where am I at? So I did times 0.25, then I did times 0.45, get 0.162. Now I'm to D. 360 times 0.15 is 54. And then 360 times 0.05 going to be 18. So that's my matrix R. What does entry R15 represent? Well, that's not really R15, it's R15, which means row 1, column 5. So row 1, column 5. 1, 2, 3, 4, 5. This is row 1, column 5. It's 23. 23 what? Well, where do we get this number? 23 was the result of multiplying 460 by 0.05. 460 biology students, 5% made an F. So 23 is the number of F's in biology. Explain why the product P times N does not exist. Well, P is a 1 by 5. And if you try to multiply that by N, which is a 2 by 1, well, the middle two numbers don't match up. They need to be the same. That's why it doesn't exist. Number 17, if all biology students pay a lab fee of $50 and chemistry students pay a lab fee of $120, find the total amount of lab fees paid by the students in these two classes. Well, how many biology students are there? 460. How many chemistry students are there? 120. So this is a 2 by 1. We need to multiply that by a 1, or by another 1 by 2. So we can multiply a 1 by 2 by a 2 by 1, then we should get what we need. So our 1 by 2 is actually going to be 50, 120, and we're going to multiply that by matrix N, which is a 460 by 360. And the reason I'm going to do this is because when I multiply, I'm going to multiply this row by this column, and I'm going to get 50 times 460 plus 120 times 360. And so what I'll get is it's $120 times 360 chemistry students, because that's how much each one is going to pay, $120 each. And this is going to be 50 times 460, which is how much each biology student is going to pay. And so the total would be 50 times 460 plus 120 times 360. It's going to be 66,200. But just a warning, I will be changing up the lab fee costs for the test, so don't go by that total. I'll probably also be changing what entry number I'm asking for and what does it represent. So you can use your review as an example, but don't depend on the answers on the review. They will be different than the answers on the test. Good luck.